Bonjour. That's French for hello. So, French is a common language. So why is it not showing up? Try that again. You know, there we go. Now we can see chapter one, or at least I think we can. So, chapter one is just an orientation. It is a sort of shotgun blast look at lots of different topics and an overview of the body and a couple of important concepts like homeostasis. By now, I hope you've watched the syllabus introduction and my study tips and my welcome videos. That's all got a lot of good information in there that I'm not going to repeat because, well, I want to streamline your time and make it efficient. So the name of the class, Anatomy and Physiology. I've already talked about that, but here it is. So let's formalize it. And I just told you I wasn't going to repeat stuff. Sometimes I will because, well, humans learn by repetition. Anatomy, the study of the structure of the body parts and their relationship to one another. So what that means is that we are going to need a name for each body part. And boy, are there a lot of names. They haven't left anything unnamed. That's for sure. And then, where are they in the body? How do we describe them? We have a series of terms, directional terms that I'll go over. And to describe where one place is relative to another. Like DFW Airport. Is DFW Airport north, west, east, or south? Northwest, east, or south? Well, that certainly depends on where you are, isn't it? DFW Airport is the name of a location, like the name of a body part. So where is it? Well, DFW Airport is west of downtown Dallas, but east of downtown Fort Worth. And that's not exactly correct. It's actually a little bit west northwest of Dallas and east northeast of Fort Worth, but what can I tell you? Arlington is south of the airport. So we can have a name and then we can use directional terms to describe where that body part is. And then physiology, the study of the function of body parts, how they work to carry out life-sustaining activities. So how do they perform their function? How do they go about doing what it is they're supposed to do? And as I've mentioned previously, this happens at the cellular level, inside cells, across the plasma membranes of cells, and oftentimes whole groups of cells cooperating together to do the same thing, to get massive results. So although they're seemingly two different topics, they're actually interrelated. The physiology, what a body part can do, is completely dependent on how it's put together. I'll elaborate on that coming up. Some subdivisions, I've already mentioned gross anatomy. That's the study of body parts that you can actually see with your eyes. Not gross as in grotesque or disgusting, as opposed to microscopic, where you would need a microscope of some kind or another. Oh, regional anatomy looks at all structures in a particular area of the body, like ear, nose, and throat. Or systems anatomy might look at just one system, like a cardiovascular specialist would specialize in cardio, heart, vascular, blood vessels, and the blood that's contained in them. Surface anatomy, that describes the structures under the skin. So you can see from from the surface of the body, you can see, for instance, some of the blood vessels running. Uh, what's called superficial is one of the terms. Superficial toward the surface of the body. That would be surface anatomy, whereas you would need a different type of anatomy to study the deeper structures farther away from the surface. And there's your first two directional terms, superficial and deep. Toward the surface, superficial; away from the surface, deep. So generally speaking, the skin is superficial to the muscles. That's not even generally speaking. That's true. There's no exceptions. So the skin is superficial to the muscles, which makes the opposite true then as well. The muscles are deep to the skin. Just like if DFW Airport is west of downtown Dallas, that makes downtown Dallas the opposite, or east of DFW Airport. Or, just to be precise, east southeast. Microscopic anatomy deals with structures that are too small to be seen by the naked or unaided eye. So we need a microscope. Ology, that's one of your suffixes on that list, isn't it? Have you made it to the ology, the O's yet on your list, making your flashcards? By now, you should be well started on your flashcards because Monday's going to roll around quickly. So cytology, sight, that prefix. Certainly you've gotten to the C's already. Sight is cell. Ology, the study of. Cytology, the study of cells. Histo, also on that list of words. Tissues, the study of tissues. Heck, there's even an entire medical department in most hospitals dealing with histology. Developmental anatomy is the fascinating topic of how things grow and change as we go through life, all the way from the very first cell through throughout the whole life. So, embryology, the study of elements before birth. Well, we don't get into too much of that. A little bit of embryology here and there. At the end of each chapter, we usually will look at the effects of age on a particular system or structure. Most of the time, is to keep in mind that this class is about how things are when they are normal. And very rarely, sometimes we will get to take a look at things that are abnormal. Young Frankenstein reference there. Abnormal. And we'll look at some homeostatic imbalances. So if homeostasis is maintaining balance, imbalance is when something goes wrong. We'll take a look at some of those, and I know that they're fascinating for everybody, but that's not the focus of the class. The focus of the class is how things work when they work well. To study anatomy, one must know anatomical terminology to be able to observe, manipulate, palpate, and auscultate. Okay, auscultate, that is listen. Listen to the sounds of the body. Like you might use a stethoscope to hear somebody's heart go, lub-dub, lub-dub, lub-dub. Palpate, that means to feel, to touch. You might palpate somebody's wrist to take their pulse. Manipulate, just exactly like that sounds, is to move a structure around to see how it works. And just observe. You might, while you're palpating somebody for their pulse, you might also observe their breathing rate. And so the anatomical terminology comes in handy here. Where exactly do you palpate the radial pulse in somebody's wrist? Well, you actually would put, let's say you want to do it on their left wrist, which is a good place as any to do it. You would put it on the lateral aspect of the carpal region, just proximal to the carpals, and the anterior side. Now, those words probably don't make any sense quite yet, but we'll get to them. Subdivisions of physiology. So a renal physiologist would study the urinary system. We already talked about cardiovascular. So physiology, just like it says here, looks at how the body's abilities are dependent on the chemical reactions in individual cells. So like I keep saying, there's only the first actual content video. It depends on it. Physiology happens at the chemical level in individual cells. So we're going to start with the very basics of chemistry in the next chapter. And more on that, of course. So to study physiology, one must understand basic physical principles. So that's what I said in the syllabus, the processes and principles. The basic physical principles are the laws of chemistry and physics. Electrical currents, and we'll be talking about different electrical currents than the ones when you plug your phone into the wall. We'll be talking about the movement of particles with positive and negative charges on them. Pressures, we'll deal with pressures a lot in A&P2, and there's basic chemical principles showing back up again. So we're going to start with the absolute basic chemistry, as if you don't know any chemistry at all, and then move through that. Well, we're going to move through that as quickly as I can. So if that is you, you don't know anything about chemistry, be prepared to spend a little extra time there. Anatomy and physiology are inseparable. Hey, that's why we jam them together in the one class. Function always reflects structure. And I'm going to reflect upon this slide here momentarily. What a structure can do depends on its specific form. Complementary structure and function. So let's look at this slide first. Whoops. This one. Here she is. Enjoying a carrot. She looks like she's really enjoying that carrot. If I enjoyed carrots that much, I'd go eat some. But we don't want to take a chunk off a carrot. We have the teeth in front, that sharp knife-like edges of the incisors on the teeth, which will break the carrot into a smaller piece, and then we can grind it on the flat surfaces of our molars into littler pieces until we can swallow it. And I think I'm going to go buy me some carrots because I'm going to the store here in a little while. I got a couple of things to get because it's Tuesday. You know what Tuesday means? It's Taco Tuesday. That's exactly right. One of the things that I don't know if you'll come to know and love it or know and hate it when I get off on a food tangent, but I love food. I like to cook. My wife likes to cook. We like to eat. We eat so good, it's ridiculous. We should open our own restaurant. What we had last night, unbelievable. Anyway, tonight we're having tacos. I got some beefsteak from the Mercado, and we are going to, I'm going to fry it up a little bit, then put it in a crock pot and slow cook it for the rest of the day. Tacos. I'll look over my shoulder. Yep, I got them. Got what I need. All right. So I think tacos are better than carrots. What else about this? Complementary. I don't even say that word right. Complementarity of structure and function. That means these two complement each other. What something can do, its function is based upon its structure. Let's talk about the bicycle. I don't have a picture of a bicycle handy. I should plug one in here. The bicycle. You know what a bicycle looks like. Think about the wheels. All right, the wheels are shaped like a disc. They're round and flat. That helps them roll. The function of a bicycle wheel is to roll smoothly across the surface of the earth. It's able to do that because of the way it's shaped, its structure. How well would a bicycle tire work if it was square and flat? I don't think you'd want to pedal that bicycle. I know I certainly wouldn't. So, structure and function. Structural organization. The human body and life in general is very organized from the smallest chemical level to the whole organism. And that's true for every life form. And organization takes energy. Think about your kitchen. Is your kitchen clean? Are all the dishes put away? Counters clean? Mine's not. I still have I got to go in there and clean a little bit. No. Does that take energy to keep your kitchen clean? It sure does. If your kitchen is clean, well, let's talk about the laundry situation. Does it take energy to keep your laundry clean, folded, and put away? Organization. It takes energy. And that's one of the important aspects of life is expending energy to maintain that organization. So here is a list of the structural organizations starting at the very lowest level of atoms. And not only that, but we'll start at a lower level than atoms. We'll start with subatomic particles, those structures that combine together to form atoms. And then atoms can, those subatomic particles, you've heard of them before probably, protons, neutrons, and electrons can form atoms of different elements, which can interact with other atoms to form molecules. And some molecules are small, like oxygen, molecular oxygen, O2, or water, H2O. And some, like a DNA molecule, are huge. They can be huge. Organelle, that's a name that means the L is diminutive, meaning little organs, and these are structures inside cells that do particular functions for a cell. So somebody thought it was cute. They're like little organs of a cell. And then we'll talk a little bit about cells, the cellular level. What is the cell? I've mentioned already, it's the smallest unit of material that we say is alive. It does all the things that we associate with life, and we'll talk about what those are. Cells can combine into tissues. Tissues can combine into organs. Organs can be in a system. Altogether, they become the organism. So let's go. Here's a level of structural organization chart. So atoms combine to form molecules. So what do we have here? Represented here, and this is pretty common in our scheme here, that the black represents carbon, the red oxygen, and blue hydrogen. And here we have a carbon dioxide molecule, one carbon, two oxygens on either side. We look over here, we see the water molecule, oxygen and two hydrogens, H2O. Notice that the two hydrogens they're not on opposite sides of the oxygen, like the oxygens are in the carbon dioxide molecule above. They're on opposite sides. In the water molecule, the hydrogens are on the same side. And that is going to be some of the unique characteristics that water has that makes it so valuable for life as we know it. So atoms, there's a lot in between right here. I'll tell you that. Molecules, the different biological molecules, which we'll talk about, molecules you've heard of before, like proteins, carbohydrates, nucleic acids. Here, this represents a mitochondrion, which is an organelle that produces energy for us. And here's a cell. It's a smooth muscle cell. You can tell because it's pointy on the ends, thicker in the middle. It doesn't have any stripes. We're a long way from talking about muscle cells. Here's smooth muscle tissue, a bunch of cells put together. Where do we find smooth muscle? Found it in a lot of places inside the body. It usually lines the hollow organs of the body, like the urinary bladder or the digestive system. And the urinary bladder, the muscles of the urinary bladder help us void the bladder of its urine. The smooth muscle tissue of the digestive system moves food through the digestive tract. And let's see. At the moment today, it's when I'm making this recording. I don't know when you're going to be listening to it, but it's a little afternoon on Tuesday. And I'm hoping at some point in the next, so say 8 hours, I have the smooth muscles of my digestive tract manipulating my beefsteak tacos. Here's another example of an organ. What's an organ? An organ is a group of different tissues. This is a blood vessel. And in this blood vessel, we have a lining of epithelial tissue, one type of tissue. We have on the outside some connective tissue, which acts in this case as a protective sheath. And in the middle, we have some smooth muscle. That's a whole story for AMP2. And I will set the stage and tell you kind of things that you'll talk about in AMP2. And blood vessels is one of them. And so the blood vessel here, you don't want to, normally most people wouldn't think of the blood vessel as being an organ, but it fits the description. more than one tissue, more than one tissue type cooperating to perform a function. And in this case, these tissues are cooperating to perform the function of transporting blood. And then we take a look at the whole organ system level. The organ systems, the cardiovascular system, as I mentioned already, includes the heart, the blood vessels, and the blood inside the vessels. And then all together, here we have, is this Ronaldo? I don't know. Ronaldo's the only soccer player I know. But the whole entire organism, the soccer player. So, requirements for life. Well, I think I'm going to make this another presentation. So I'll cut this one off here. Say, maybe. It takes me time to click between things here. So I said hello in French, so I'll say au revoir.